Hey everyone, thank you for attending. It's been an exciting day so far, and I and my teammates hope to keep the excitement going. So we are building the future of inference on top of Ray and vLLM, and we are going to talk about our journey on building the inference stack ground up at DigitalOcean. So for those of you who are not aware who DigitalOcean is, uh, we are. We are the simple, comprehensive agentic cloud. We had DigitalOcean has prides itself in building simple, cost-effective solutions for our customers across layers as an infrastructure, platform, as well as application layer. With the next-gen apps that we are bringing on, we are focusing on gradient AI, where we are building right from GPUs all the way to AI agents and apps in cloud. I and my team are going to talk about this cloud here to you. At the DigitalOcean AI Agentic Cloud, we are going to focus this discussion only on how we have built the inference stack. So within the inference product lines, we have a couple of different options. The first one is where you control and you have more customizations. So you manage your inference workloads at the GPU level. That's our dedicated inference offering. The other one is where DigitalOcean takes the stress away from you of managing multiple accounts, multiple model providers, managing, maintaining multiple workflows, and distributed billing. So we provide to you a single key that comes with a single bill at the end of the month that you can use to access cutting edge models from across a spectrum of model providers, such as Anthropic, OpenAI, Meta, and there are more exciting models coming onto our platform. With that said, we'll dive deeper into how we have built the inference stack. This is built on vLLM as well as Ray. And I would pass it on to my teammate, Boopathy, to talk about serverless inference next.
Thank you, Yogesh. Today I will just walk you through the overview of the serverless inference um, and also how the developers access DigitalOcean serverless inference platform. Uh, the serverless inference platform is built on top of Kubernetes and Ray. But developers can interact it through Gradient SDK or a simple REST API. These abstracts away the complexity and provides the consistent interface for all inference requests. As you see in diagram, so there are two different layers, serving layer and hosting layer. All the requests will come first it's on the serving layer, which acts as an intelligent gateway to the platform. It covers the four major functions, such as authentication, authorization, rate limiting and quota enforcement, usage tracking and metrics, and multi-backend routing. Now let's move on to the hosting layer. The hosting layer is the engine room of the platform. The hosting layer is built on Ray service. We have designed it around four core capabilities as listed there: the dynamic model loading and configuration, continuous reconciliation, scalable model serving, and observability. Together, the serving layer and hosting layer create a fully managed intelligent inference platform. Developers can invoke any models using same unified API, while DigitalOcean handles routing, orchestrating, scaling, and monitoring. Under the hood, DigitalOcean Kubernetes provides the reliability and foundation, while Ray service gives us dynamic orchestration and continuous reconciliation. In essence, the DigitalOcean serverless inference platform brings together the best of both: the simplicity of the serverless API for developers and the power of Ray for distributed high performance model serving. So with just few lines of code in Gradient SDK, developers get access into fully managed production grade inference environment. Um, Now I will hand it over to Damodar to talk about optimization.
Yeah, thank you, Boopathy. So, as we went GA earlier this year, with increasing customer demand, we quickly realized how important it is to be very efficient with our resources. We therefore started applying some of the optimizations to our stacks. We started with something called prefix-aware routing. So this optimization targets the most common workloads that we saw, which is multi-turn chat applications or agentic workloads. The core inefficiency of the distributed system in the inference is every new turn in the conversational chat might get routed to a different node. This forces the GPU to reprocess the entire chat history, which is a massive waste of resources. So our solution was twofold. We enabled the KV cache at the node level. So the KV cache slash artifacts that were processed by the previous turn are stored, are not discarded. And we added an intelligent router at the top to basically have the stickiness in the conversations, and thereby the subsequent requests are routed to the same node. Therefore, we reuse the KV caches that we created previously. The impact was significant for our customers. We reduced the P99 of the time to first token by 70% for these workloads. We also introduced something called SLA aware routing. So we understood that our customer use cases demands different capabilities. Some of the workloads demand absolute latency sensitiveness, and there are other want to focus on the throughput and cost effectiveness. So, and because our backend had multiple flavors of hardware like NVIDIA GPUs, AMD GPUs, we added this intelligence in the routing layer to take advantage of these different capabilities of these hardwares and serve respective requests. To further attack on the latency, we are currently working on introducing speculative decoding in our stack optimizations, where we are using a smaller draft model, we call it, to generate a set of sequence of tokens, and then use the larger actual model to validate those tokens in a single forward pass. With this optimization, we plan to significantly boost on the overall throughput, not just on the time to first token, but also on the time to intermediate tokens. We also are working on introducing pre-filled decode disaggregation. We all know LLM inference is two steps. Pre-fill stage or step is compute bound. The decoding stage is memory bound. So we want to take advantage of these specific phases by serving these two steps on different hardware to cater to good throughput. So to summarize, we continue to push the boundaries and pass the performance efficiencies in terms of speed, latency, and cost directly out to customers. That's the journey we have been. And with that, I will pass to Debarshi.
Thank you, Damodar and team, for the excellent overview of the Gradient AI platform on serverless inference. Now, when you are starting up as a startup, then almost always you are going to start with serverless inference, because you do not want to reserve the GPU capacity and you do not want to pay for that continuously. Rather, you pay as you go, and you can get instant access to all the popular models, popular foundational models that you need access to. So due to those reasons, you are always almost going to start with the serverless inference. But when you scale to some limit and you are paying over a threshold, then it may make sense to actually reserve that GPU capacity and optimize your models on top of that so that you can get the best cost performance out of those GPU capacity that you have purchased. So for that, customers are asking us to launch something like dedicated inference, where you are not sharing with the multi-tenant customers, but you are having your own dedicated GPU capacity and running optimized LLMs on top of those. So for those, we are going to launch dedicated inference very soon, which will sit right in the middle of serverless inference as well as the hosting directly on the virtual machine. So on the right side, you can see that is called Droplet, which is nothing but virtual machine that we call at DigitalOcean. So on the virtual machine, you can run anything, right? You can run your own server, you can run your web service, you can run data processing pipeline, or you can host a model if you want to. But hosting the model is not very easy. And especially if you want to run at the production scale with all the fault tolerance, with all the 3 nines or 4 nines of availability and all of those, that is not easy. That takes like a lot of tuning, lot of optimization and all of those, and production level availability. So you will have to procure the virtual machine, then you need to run the software stack on top of that, and you need to keep upgrading, like your server and your LLM processing engine will keep upgrading. You need to keep upgrading your stack and keep updating your even the infra layer. So all of those takes significant time and energy from you. So our customers are telling, like the signals we are getting from the industry is like, hey, you take care of all of those when we do the just focus on our application building. And that's what like customers should do. Like you just focus on your application building so that you don't have to take care of all the infra layer, all the software layer to run the model hosting and LLM. So that's what we are going to mainly offer. So if we do a little more deep dive on what you need to do to host LLM on your own, to see the complexity that it entails, right? At the bottom layer, you can see that there are GPUs. So you can use NVIDIA GPU, you can use AMD GPU. You can see like which one has the best performance or the right cost for you. And with that GPU, you also need to have the GPU interconnect and also the networking and the file system, because you may want to run on NFS so that you don't need to download the same model again and again when you scale out. And you want to reduce the time and cold start latency for running those models and whenever you scale out. So for those reasons, you will need to access all of those data center level primitives, right? You need to tune all of those. And on top of that, you want to create the auto scaling so that the capacity you have procured, like you can efficiently use it and scale out and all of those when you need. And of course, on top of that, you have load balancer and smart routing so that you can route where you will get the best latency. And you are not routing like blindly without any metric. So that is all your infra layer you need to tune and harden. At the same time, on that infra layer, you want to host the inference runtime. So the inference runtime has a lot of things that you need to deep dive and you want to tune. And you need to see what is your business objective. You want to reduce the latency, time to first token latency, or throughput you want to increase. So based on your business requirement, you want to tune those layers. So you can see like, I don't want to go into details of all of those. But yeah, so there is batching so that you don't take you don't wait for the longest request when you can return for the shortest ones. Then there is attention algorithm, memory management. You don't want to like fragment your GPU memory and like waste your memory so that you can have less caching. And then of course there is caching where you can do prefix caching, KV caching so that you are not wasting GPU cycles doing the same computation again and again when churning out the next token. So all of those tuning you need to do, you need to understand those concepts and optimize. Now what our customers are asking that, hey, you take care of all of those. I just reserve the capacity. I tell you what is the model you want to run. And then I just focus on our business application. You take care of all of those. So that's what we're going to do. And so this is just to show you like what all it needs to achieve the production scale inference hosting. So yeah, for the use cases, I'm not going detail because I'm running short of time. The benefits will be you will run dedicated hosting where you are single tenant customer. You are not sharing those GPU infra with any other customer. So this will be constant resource for you, and you'll be also paying the constant amount of cost for that one. Plus, there will be like control. So the one benefit that you will get and will release in different cycles is that will allow you to configure many different levels of the stack. So those are the things that we'll be launching. And of course, the best price performance. You can select NVIDIA GPU or you can select AMD GPU and you can see which one works best for your cost performance. So there is a lot of tuning and a lot of flexibility you will get. So that's what we are going to launch. If you're interested, please talk to the DigitalOcean booth that we are hosting. Please come join us and talk to us. With that, I'll give to Yogesh. Thanks.
Yeah, thank you. And as we as we talk about what we have built so far, there's still a long way to go for us. So what we are looking forward to is building the future frontier of multimodality. If somebody wants to build a video game, somebody wants to translate their training videos across geographies, somebody wants to make a movie, or you want to make your podcast available in the language that it was not recorded in, those are the kind of those are the example of apps that we are looking to support as we scale on our Gradient AI platform. So we'll look to provide the model composability, model chaining, your workflow chaining using agents as well as your model use cases. We are looking to do that with taking care of how the model is going to respond, how the response is going to be handled, and its storage on the Gradient AI platform. As we scale from developers to also developers in digitally native enterprises, there are going to be concerns about privacy and data protection. So DigitalOcean looks to provide you with protection like VPC, role-based access, team-level enterprise access segregation. So those are some of the features that we are looking to roll out. On the Model Studio itself, our team is working on and will launch some of these features soon, such as fine-tuning, bringing your own models, enterprise governance of your models, and for the safety and security of your workloads, enterprise-level guardrails. There's a lot to talk about, but I'll pause here. If you, as Debarshi said, if you have any questions, we are at the booth G4, and we would love to chat with you. So thank you once again for attending and for listening to us. Thank you.